In the vast, awe-inspiring theater of the cosmos, there exists a phenomenon more profound than any other.
Okay, so set it up.
A spark.
Wait. That's Mark. Yeah, right, Mark.
The spark of imagination.
Alright, get your power's on, right? You all set up? Power's on? Alright. 2.
Once lit,
Go.
the potential is infinite.
We have main engine start. 4, 3, 2, 1, 0. We confirm ignition and the thrusters go. Feet per second. Altitude 177 nautical miles.
It is this very spark that has ignited the relentless curiosity of humanity for generations. We are captivated by the notion of unseen worlds, places yet uncharted, unexplored, and unimaginable. These are the frontiers, and these are the pioneers. NASA and others pushed the limits of science, engineering, and the human body to enrich our everyday life with their innovations. If we see further, it is because we stand on the shoulders of these giants. In 2012, the Space Shuttle program was retired. These magnificent chariots that built the space station and more rest in museums now. With their engines silenced, human spaceflight was no longer in the public eye, and it seemed as if interest in life in space had all but disappeared. But the spark remained. And today is ignited by the funding and imagination of private companies working in partnership with NASA and other international space agencies. Together, they are embarking on new and evolved missions to low Earth orbit, the Moon, Mars, and beyond, that one day soon will transcend the knowledge and scale of the Golden Age.
Let's go.
What these programmers, engineers, inventors, and astronauts understand is that at the limit of all that is possible, there remains more to be found in the realm of the impossible. The first challenge in space travel is leaving Earth. This thin band of atmosphere is a formidable boundary between us and the stars. First crossed in 1961 by the Russian Yuri Gagarin, and hot on his tails by American Alan Shepard. To break free of Earth's gravitational pull, a spacecraft must achieve an incredible velocity of approximately 33 times the speed of sound, or else it will crash back down to the ground. To reach this speed, known as escape velocity, requires millions of gallons of rocket fuel. But one new company hopes to get to space with a launch that requires no rocket fuel at all. The CEO of Spin Launch and his team have just launched a rocket into the sky, and it has landed somewhere in the desert here in New Mexico.
Oh, yeah! There it is! Check it out! All right, look at that! It's in one piece!
You know, it's worked every time, but I think that when you start to get a little too comfortable is usually when things tend to go wrong with complex systems, especially systems that have never been built before.
It's actually in pretty great condition. I mean, there's some scuffs, but I mean, my initial indications, it could probably launch it again.
We are building an alternative space launch system that will dramatically lower the cost of access to orbit. It is really a structure unlike anything you'll see on this planet. It's science fiction brought to life, and it's massive. It towers 165 feet over the desert floor. This is the test flight system, but it is the step on the way to us building our orbital capability. It is a 1/3 scale version of the orbital system.
All right, launch vehicle looks good. Scott, get the back.
Coming up!
Inside is a giant electric-powered motor that spins its payload into the atmosphere at 5,000 miles per hour, avoiding rocket fuel's expensive and polluting downsides. Engineers and inventors at Spin Launch have pushed boundaries beyond what was thought possible to electrify space transportation. NASA, Airbus, and Cornell University are participating with this launch to test small payloads and see how they fare under such an intense launch environment.
This is Spin Launch's suborbital accelerator, and I'm here because I'm fortunate enough to have a test payload being launched out of this accelerator this afternoon.
A vacuum-sealed centrifuge eliminates any air particles that would cause friction on the spin. The rockets and rotating arms are made of carbon fiber, one of the strongest, yet lightest materials invented to withstand the incredible forces required to catapult the rocket into space.
Disabling motor.
Motor disabled.
Enabling floodlights.
Floodlights on.
All right, we are ready for launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Release.
one 3 times bigger, pointed towards space, and beginning launching satellites 5-10 times a day, and really building the future of a low-cost space industry.
Escaping Earth's atmosphere is no easy feat. To make it more sustainable and affordable is an important step in the global space industry. SpaceX is a pioneering company that kickstarted the private space race by painstakingly building rockets that are completely reusable, with funding from NASA's commercial cargo and crew programs. To land a rocket is a manufacturing and engineering marvel. Landing their Falcon 9 booster back on Earth proved more difficult than imagined. There's almost no room for error on a near empty tank. After years of test flights and technical refinement, NASA has embraced these rockets and now trusts SpaceX with their own cargo, even their most precious cargo of all, the astronauts.
It is incredibly exciting flying with SpaceX and having the privilege to fly on a new Crew Dragon. I feel like getting to fly to space is a once-in-a-lifetime opportunity.
Come on, 15 seconds.
And what an amazing time to be a part of human spaceflight.
Freedom soars. The Dragon flies forth. Vehicle already pitching downrange. All 9 Merlin engines have to lift. Propulsion is nominal. Getting good performance on stage 1 propulsion already. The retraction of the docking ring is underway. Slowly see Dragon inch a little bit closer to the docking adapter.
And SpaceX on Dragon to ground. No response required. For your awareness, we'll be clearing the RGPS-1 alert shortly.
This is the ISS, the International Space Station. For over 20 years, this amazing spaceship has passed over the heads of everyone down below every 90 minutes.
So we have a government space station. It's been in orbit since 1998, populated since 2000, and it's been doing world-class science in that entire time. I spent 20 years at NASA as an astronaut. I flew 4 times, 3 of them on the space shuttle and once on the Soyuz to the ISS. And during that time, I was fortunate enough to do 10 spacewalks. My last spacewalk was in 2007. and I miss it. I am Michael Lopez Alegria, and I am the chief astronaut at Axiom Space.
Since its inception, the ISS has been at the forefront of scientific discovery. But like all vehicles, it too is wearing down. NASA, in cooperation with the private space station company Axiom Space, have ambitious plans for its future. Axiom Space modules will latch onto the ISS to kickstart the build of the Axiom Station. Once built, the ISS's mission is complete and is expected to vaporize upon deorbit into the sea. But from the ashes, a brand new space station will take its place. This evolving relationship between NASA and private companies brings new opportunities for hundreds of countries and companies seeking new knowledge, profit, and adventure in the arena of Earth's low orbit. The microgravity of space is a unique laboratory condition for new discoveries in medicine and manufacturing. Tissue engineering, cell research, and optical fibers all benefit from no gravity compressing their form as they are manufactured in space. The opportunities are so immense that more companies are wanting to build their own space stations. Soon, ordinary people will be living and working on private space stations as citizen astronauts. And all of these orbital workshops above us will be lifted by the innovations and creations of the people down below. And new innovations in the cost and speed of manufacturing are essential to maintaining the pace of space station development. At Relativity Space, they are using 3D printing to build rockets, reducing vehicle complexity, cost, and the time frame of manufacturing from years to weeks. Relativity used the world's largest metal 3D printers to efficiently produce nearly 85% of their Terran 1 rocket. Like all new space technology, 3D printed components will require extensive testing before they're ready for commercial use in just a few years. The pace of innovation in space technology is also advancing the evolution of robotic and artificial intelligence to perform tasks on crewed or uncrewed missions.
This is Robonaut 2, one of our previous robot designs, and if you think this looks cool, wait till you meet Valkyrie.
this arm, feed this cable through.
In this lab space, we are designing robots for use on the lunar surface and eventually on Mars, where humans can't be there or where it might be dangerous for them to be.
Some of the greatest explorers of the universe are cameras and robots that go further than humans are ready for.
Alright, back from space. These tiles are tesserae. This is my PhD work that we're now developing at Aurelia Institute. These are the miniature tests. They just came back to the International Space Station. The way these tiles work is that they self-assemble in microgravity when they're floating. These magnets are drawing them together. They pirouette and they bond at their edges. And so that's what you're seeing here is this frame of a future space habitat at human scale following the tesserae pattern. I love big picture questions about life in space, from cosmology and astrophysics to the everyday engineering of the tools and the things that we need to survive and thrive in space. How do we build infrastructure and habitats in orbit that can house hundreds of people, even thousands of people? Space exploration is not a plan B for taking care of Earth. We know more about climate change and what's happening on this planet because we sent probes to Venus and studied greenhouse gases. Everything we design for life in space can come back down and benefit life on Earth, this really treasured, perfect, beautiful blue planet where we live right now.
Technology is improving quickly, and there will soon be millions of pieces of junk satellites and discarded pieces floating in Earth's low orbit. It will certainly be a challenge for future spacefaring garbage collectors. The growing achievements of these space engineers means that thousands more people will get to visit space. But being an astronaut is about more than just leaving Earth's atmosphere. It's about exploring new worlds and finding just what's out there in the universe. If our aim is to become a multiplanetary species, we need to go back to our very own alien world. The moon. All manned missions to the moon stopped a long time ago. Not one kangaroo bounce or round of golf has been played there since 1972.
Man, I'll tell you, Andy's never seen a driver like this. When those wheels really dig in, John, when you turn is when you get the rooster tail. Okay? Man, that was all four wheels off the ground there. Okay, Max, stop. Okay, I don't want to do that. Okay, excuse me.
But after more than 50 years, NASA and its partners are getting ready to go back. Spanning multiple years, the Artemis moon program encompasses a variety of extraordinary missions. Artemis 1 signifies a pivotal milestone in lunar exploration as a test of the Space Launch System and Orion capsule. Artemis 2 will fly a crew around the moon to further test the spacecraft's capabilities. While Artemis 3 will mark one giant leap for man and womankind as it lands 2 astronauts to the surface of the moon, where the duo will embark on long-term experiments on the lunar South Pole. The most crucial part of these missions comes at the end, and that's getting back in the Orion capsule.
Be moving so fast, the friction is just going to ignite the air around it. Plasma's going to form around it, and that stuff is going to be flowing and moving, and the heat shield is going to be dissipating that energy. And it's protecting the structure and the systems and the people underneath it. I'm NASA astronaut Victor Glover, and I trained to fly in space, and I also help folks that are training to fly in space. And we are in the Space Vehicle Mock-Up Facility at Johnson Space Center in Houston, Texas.
A former Navy pilot, Victor Glover flew the first operational flight of a private space capsule to the International Space Station. Victor is one of 4 astronauts selected for the Artemis 2 flyby mission to orbit the moon.
This is the vehicle that humans are going to fly to the moon. This is a self-contained unit. So on the first Orion mission that a crew goes on, Artemis 2, the crew is going to live in this vehicle for the duration of that mission. It'll be about a 2-week mission. And so we can use this to test out suits, seats, where we're going to run cables for cameras and things. Human spaceflight requires you to be good at everything. All the stuff that's out there, the biology, the engineering, the computer software, all of it has to work well. So understanding the complexity of what we're doing, it really turns for me into wanting to train to the best of my ability.
This is NASA's Neutral Buoyancy Lab. The enormous swimming pool is the best simulation of zero gravity for astronauts to train. For years, this lab has trained astronauts how to build and maintain the International Space Station. And now has new lunar training grounds for Artemis astronauts. In addition to debris, there are millions of micrometeorites that could cause havoc at any moment.
Give me a second, I'm just trying to get you stable. Roger.
Solar radiation and extreme temperature make spacewalks incredibly dangerous. Muscle memory and making decisions under pressure are crucial.
It looks good right there. Is in line with the expansion. Roger.
Now, if there are strong emotions, when I worry or when I feel anxiety most, it's for my family and for the families of the crews. And so, that's the part that when I'm strapped into this vehicle or some other vehicle launching, they're watching, but you're not there to help them through that challenging situation. It can be great when it all goes well, but it can be a really challenging emotional situation. So that's the part for me that is the toughest.
After 2 previously scrubbed launch attempts for Artemis 1, in Florida, there's hope that this time weather holds and conditions are just right for another trip to the moon.
I'm glad that we are at the Kennedy Space Center and rockets are launching. I mean, I say that with such enthusiasm in my heart that we are going to explore, whether it be at the space station and the moon, I don't care. Let's just go somewhere.
At the Kennedy Space Center, engineers are making the final adjustments to NASA's most powerful rocket ever. The SLS, Space Launch System. It is capable of reaching 24,000 miles an hour. Named after Artemis, goddess of the moon and the hunt. Built in collaboration with over 1,000 different companies, Artemis 1 is making its way from the vehicle assembly building to the launch pad. The crawler transporter is as complicated as the rocket itself, and every time it is used, it slowly brings us forward as a spacefaring species. While Artemis 1 is a test flight, this same system will one day carry astronauts to the moon and to other deep space missions. This is the Lunar Gateway, a proposed collaboration between NASA, private companies, and international space agencies. Envisioned as a refueling and scientific research station where astronauts will live and work in a permanent orbit around the moon. It is strategically linked to upcoming Artemis and deep space missions. Artemis 4, for example, will dispatch astronauts to dock with the Gateway Space Station, where in collaboration with the European Space Agency, they will undertake a moon landing. The moon base will support human and robot activities on the lunar surface. Research in mining and processing the ice on the moon's surface in water, and rocket fuel are essential to building the structures we need to venture out further into the solar system. It will also test our astronauts to live and work in the hostile environment of deep space. Skills we'll need to visit Mars or beyond.
Got a problem here.
We are on the Space Coast here in Florida, and that is the Artemis 1 stack up there, the SLS rocket and the Orion spacecraft that were sent to the moon.
6, 5, 4, 3, 2, 1.
Big things I love about this mission. It's sort of taken the stick from Apollo and Shuttle and ISS, and now we're taking the next leg of this relay race. Now we're focused on the moon, but then eventually this mission is going to hand that baton off on this relay race to Mars. I have to pinch myself because this is real. You know, I get to be a part of this. And it's just amazing. Like it's pretty surreal.
That sounds good. We sound like we've probably got enough of the Grand Prix. We're willing to let you go on from here. Come on, that thing is fantastic.
Some of us may leave this Earth to discover the new frontier. Our descendants may be born on the moons of other planets. We can see immeasurably far into the vastness of space. The potential is infinite.